Okay, one last way we can look at impulse, you guys. We've got impulse is force times change in time, which also equals mass times change in velocity. This assumes the force is constant. We also have impulse where we have the area under the curve. All right. Sweet and nice and easy if we have a graph and it's nice shapes. There is one other little trick that we can use. Let's say we have a crazy, ugly graph like this, right? And the force varies something like that. We're figuring out the area under the curve could be, well, mighty unpleasant. In this case, there is one other possibility, and the possibility is cheating. We're like this. If the force looked like this, it would be super easy to look at. All right, because you'd be like, oh, sweet. It's just a rectangle, length times width. But we don't know what the value would be here. By definition, this is the average force. And if we have some way, or they've told us the average force, then area under the curve can also be equal to average. That little bar means average force times the change in time. Sometimes they will just flat out tell you, this is the average force, which just means, look, I'm being easy. Sometimes you will have a graph and you will have to somehow cleverly find average force. Or a lot of times, let's say you're doing it electronically on Logger Pro, which we'll do on Monday, you can highlight the section and say, hey, give me the average force, and then you measure the time, and then you're home free.